Hello, folks. Thanks for taking a look at today's blog. What I'm going to be covering today is 3D print or print for 3D. Some steps and some tricks to take to get some things inside of 3D printing. These are things I've kind of learned over the past year that's kind of useful. So, this does kind of represent multiple printers, but this is really specific for the Mark Forge. For this particular blog, but this, again, could utilize these kind of scenarios in other printers because I have seen them use the same type of technique that we do. And I will explain what I'm referring to here in a little bit. All right, so the first thing we're going to look at is design for print. All right, so we got a part here that is typically, it's a usable part. We can print that, no problem. But the customer, at first, we would talk, this is a machine part. So they're trying to get rid of as much bulk out of the billet aluminum as they can, and utilize some strength here. But again, this, in our printer, we don't have to necessarily worry about like internal voids to reduce weight and things like that. So in this scenario, I have two comparisons here. I have the exact same bracket with and without the internal void. All right, so let's look at some scenarios between the two. So first off, we're looking at a 14-hour and so roughly 15-hour print time for the one with the pocket. Without the pockets, we're looking at a 10-hour. So you're looking roughly saving, several hours of print time here, 4 or 5 hours to get the same result. And by same results, I'm talking about the material volume used. So if you look down here at the very bottom where my cursor is highlighting, the plastic volume on this solid part is 62.72 centimeters cubed. And on the one with the bracket, it's 61.2. And you're wondering, how's that work? Well, of course, on the Mark Forge printer, if we look at the internal view here, of course, we do print the internal supports. I have the two set to the same settings. And if we look at our internal supports here, oops, not that. I want to look at, turn off everything, and let's just look at the entire triangular infill. So, by default, the software has an algorithm, and it's going to create this rectangular, triangular, or hex mesh infill of your preference and of the density that you prefer. So you're going to get this triangular infill regardless of whether you hollow it out or not. So that's why taking all those pockets out really didn't do anything for me other than take more time to print. Because the strength's going to be the same, the volume of the plastic is the same, and of course the cost of the part is roughly the same, 14 here to 14 here. All right, so without having to take all that time to add all those other features in there, of course you're also saving time in CAD, not having to have all these types of pocket features in your geometry. All right, so on to the next scenario, something very similar. We have another part we're taking a look at here. This is kind of a thickness gauge. It's a pretty simple part. Once you just stick a part in there to see if it's the right part to go to the right place. So we have some mounting points and things like that that are located. We're looking at a 25-hour, roughly 25-hour build time for this one. All right, so let's take a look at the next scenario where taking some material away does make a difference. So here, we're looking at 22. So, well, that's only 3 hours difference, and it looks like a lot more materials removed from one part than the other, and that's true. If you look at the volume on the part that I carved away some geometry, we're looking at 129 roughly, and on this one, we're roughly at 167. So, almost 40 centimeters cubed of extra material wasted on a part that really doesn't need all that extra space. But the time saving wasn't all that big deal. So, you have to kind of just weigh what you want. You want a faster time, less material use, stronger parts. So there's kind of a formula that you can run in your head. All right, so I need it really quick. I don't need the strength. So you can always bump down the internal volume, again, under material settings. You can turn down the fill settings. Of course, we get a warning here because it tells us, you know, there is a specific set. So by default, the parts are going to be really strong. So, you know, if you don't need that strength, you know, you're not going to have to worry about that. You can always take some of that time out of the build and material out of the build. But all these things I'm comparing, all these things right now I'm comparing are pretty much apples to apples, all based on the same amount of fill scenario here. So again, saving material versus time, and on this one, saving time versus material. All right, let's take a look at some other material saving steps. All right, so designing your, again, this is a design for printing kind of scenario here. Having support material where in areas sometimes you don't want it, or trying to alleviate support materials altogether. All right, so we have a little block here. So we have 44 degrees on one side, 45 on the other. So again, let's look at the internal view. All right, so we have our part here. We have the 44 on the left. Let me rotate this around so it is on the left. And the 45 on the right. Of course, what we have here is a scenario. 45 is kind of the magic number where support material is not needed to build, to have areas above it being built. All right, so that 1 degree makes all that difference. All right, in another little scenario here, let me turn on the visibility. Let me turn on the infill. Let me turn everything else off. Turn on the infill. Oh, sorry, not infill, support. Sorry. Zoom that up. All right, so it's kind of hard to see on this model, so I have it pulled up in Solid Edge, what we're referring to. I have the same model here, the 44 and the 45. What I'm kind of referring to is the interior hole, so that's kind of easy to see on the outside. Something to keep in mind on the inside of your geometry when you're printing holes and things, you know, some blind holes or some things that need inserts. If you don't put a little cone at the top of your part here, or the hole, well, what's going to happen is you're going to get support material in there. So you notice this one, for example, this round hole right here. This is the hole. So here's the two straight holes, which typically is a scenario you see. You know, somebody would machine a hole through, and you machine a hole from the other side. And in that scenario, you're going to end up getting a lot of infill in here, which is kind of hard to get, or support material that's hard to get out. All right, so you notice on this one, we have zero support material out. There is just none. With that 45 at the top cone, it doesn't require any infill. On the scenario where we need two holes, one from the bottom, one from the side, if you put one hole with a cone at the top and the other from the side, and when you, so in this scenario, you want to put the second hole a little bit lower than the 45 degree at the top, and you'll end up with very little support material. So I just have a little bit of support material in that outside hole and very little, just one little piece on the inside. So that would be very easy to clean out. So that is working with holes and working with overhangs. If you can keep them, you know, at roughly 45 and less, you're going to get no support material required. All right. Of course, I hate to throw a wrench in there, but that's not a wasted scenario. So in a case like this, we have a part. This one is 46 degrees. But if we look at the internal view and turn it on the side, you can see the support material here required to build this overhang. So just to kind of give you an idea, this is actually the part here. And if you look at the angle of this, this is actually less than 45. So we got, you know, 46 degree, or actually, sorry, less. So we don't, greater than 45. So we don't need that overhang there support. So in our software, unfortunately, all curves like that are not created equal. So sometimes you'll get less than 45 in a certain area. Well, it's going to throw support material in there. So it just, sometimes you can't get away from it. But on areas that are flat and you just have a 45 machine face, then, but you know, keep it at 45 and less, and you should be good to go. All right, so moving on. All right, another little print trick that I kind of came up with here recently. Well, I didn't come up with it, but I'm sure somebody's done it before. Printing some extra geometry to alleviate the support material. And this is a little bitty battery cover working with. Of course, this may not be the best orientation, but I do have some, you know, little symbol. Maybe you have some text on the front of this that you don't want to print. Typically, you'd print it on the side, and that would be the best thing to do. You would have zero support material, but then again, you'd have a lot more support material down in these little cracks that would be really hard to get out. So printing in this orientation would be the best to do. All right, so let's take a look at the internal view of this part. All right, so here we have our internal view. And of course, all this little shaded area is our support material. So if I turn off everything but the support, you can see it's a substantial amount of support material. And it wasn't really hard to get out, but a lot of times when you want to have areas that you don't want support in, for example, this little area right here, if I didn't want any support material on this face that goes up to this face, well, I did this and it works perfectly fine. All right, so in my 3D CAD, I just print an extra part, and I just print this kind of interior little volume of this shape, and I leave a point, I left the 0.01 gap between its face and the face above it. All right, and what that does, if we look at the internal view, all right, so we have no support material now in this little area. So I kind of alleviated that completely by having a 45-degree face here and kind of extruding that out. Of course, everything else at the top worked out the same. So for example, let me show you what I came up with once I printed it. So this is for the top one. As you can see, I have those little extra part I printed in CAD, and of course, all the support material was out. It took a little extra. You can see all the extra little support materials that I printed, but we're looking at 9.4 grams of material compared to the 10.6. So very little extra material printed to have this come out pretty much one piece and just have these little top pieces that went inside the little bump area here. Most of those came out. One came out with the bracket, but the others just pop right out. So very easy to accommodate that with your CAD by adding some extra geometry into your parts that would facilitate printing without support. All right, so that's all I have for you, and I appreciate the time you took to look at this. If you have any questions, feel free to contact us at Swoosh Technologies. We'd love to talk to you about our 3D printers or anything else in CAD that you would like to talk about. All right, thank you, folks. Appreciate it. Bye-bye.